All right, good afternoon, class. It's Mrs. Harding here. Sorry that I haven't been here for a couple days. The earliest I will be back is on Friday. Okay, so I have a couple videos for us that you guys can be watching today as well as tomorrow. Hopefully this will clear some things up. Obviously, use each other as a resource, use your book as a resource, and also go to the tutoring center. Okay? Like I said, I apologize I'm not going to be there for a while, but I'm going to do my best I can to get you guys caught up with these videos. So last night, you guys are supposed to do homework on what's called synthetic division and substitution. Let's go quickly over some things that we got out of the book last night. And we're actually going to start with synthetic division first. Okay, so with division, there's a couple of rules that you have to remember. This only works for when the divisor is a linear polynomial. Remember that linear is degree 1, and the divisor is what you're dividing by. So for example, x plus 3 works. Okay, x squared plus 3 would not work with synthetic division, and you would have to use long division to finish that problem. Okay. Another key thing you guys have to remember is that the leading coefficient of the divisor has to be 1. Okay. So for example, 2x plus 4, the leading coefficient isn't 1, so we would have to manipulate it to make it 1. Okay, so the leading coefficient of the divisor has to be 1. All right, so make sure that you guys have your homework out in front of you. I'm going to go through some of these problems, even though you guys had the odds to check your answers, but just so that you guys can see what to do. Okay. So the first example is going to be number 25. Okay. And we have x to the 4th minus 3x to the 3rd plus x squared minus 5, all divided by x plus 2. A couple things you need to remember here. First of all, that this has to be a linear polynomial, which it is because it's a degree 1. And the leading coefficient of the divisor has to be 1, which it is. Okay. Now how you do this, you're going to take the opposite of the number that you're dividing by. So this is going to be negative 2. And you're going to put a little backwards L shape. Okay. Then you're going to write down all of the coefficients. 1, negative 3, 1. Okay, yes, I know I'm not done, but we run into a problem here. Just like with long division, you have to insert a 0 for all missing terms. So we're missing a degree here, x to the 0 power, or excuse me, x to the 1st power. So we're going to put a 0 in and then negative 5. Okay. Please, 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 do not forget to insert zeros for missing terms. All right, first thing you do is you're going to drop this down. So we just have 1. Okay. Then you're going to multiply 1 times negative 2 and write it in the next column over. So we get negative 2. Add this together, negative 5. Then you're going to multiply again. So negative 2 times negative 5 is going to give me a positive 10. Add these two together, you get 11. Then you're going to multiply these together again, so negative 22. Okay. Add them together, you get negative 22. Multiply, you get 44, and then you get 39. All right, so remember that, well, hopefully not remember, but you saw this yesterday in the book, that this is considered the remainder. Anything to the right of that bar is the remainder. Now, when you go to write your answer, if you have a remainder, remember that from long division, it's the quotient plus the remainder over the divisor. Okay. Now, we started with degree 4. Okay. So when we write our answer, we're going to start with degree 3. And these are all of the coefficients that are going to go in front of those terms. X to the 3rd minus 5x squared plus 11x minus 22 plus 39 over the divisor. So remember, once again, that since we started with degree 4, then we're going to start with degree 3 down here. Okay. You just minus the degrees by 1. These numbers down here are all the coefficients in front of the variables. All right, let's take a look at 27. Okay, first of all, you have to check to make sure that you're working with a linear divisor, which we are, and that the coefficient is 1, which it is. Okay. So take the opposite number here, so 4, put it in the backwards L, and then you have to make sure that all degrees are accounted for all the way down to the constant. So we have 1x to the third, negative 4x squared, 0x, 0 for the constant. Drop the first number and multiply. So 1 times 4 is 4. Add these together, that's 0. Multiply, 0. Drop it down, 0. Multiply, 0. Okay. So what you should get then is, notice we don't have a remainder because it's 0. You started with degree 3 up here, so that means you're going to start with what degree down here? Hopefully you said x to the second. 1x to the second, or in other words, just x to the second. Okay. You don't need to write 0x plus 0 because anything times 0 is just 0. So your final answer is x squared. All right, so let's take a look at number 29. I'm just going to go ahead and set it up for us instead of rewriting it. So negative 4 goes on the outside, and then you write down the coefficients. So 1, 3, negative 5, and negative 4. Okay, all powers were accounted for, so you don't need to insert any missing zeros. So drop down the 1. Okay, you multiply, negative 4. You add, negative 1. Multiply, 4, add, negative 1. Multiply, 4, add, 0. So notice that the pattern is multiply, add every time. So multiply, add, add. We don't have a remainder. Okay, we started with degree 3, so that means we have to start with degree 2 in our final answer. So 1x squared minus x minus 1, or just write it as x squared minus x minus 1. Okay. And then, of course, you guys can always check your work by taking what you got for the quotient, multiplying it by the divisor, and making sure that you get the dividend. Okay. I think these were supposed to be y's, but it's not really that much big of a deal. Okay. All right, let's continue on. Let's take a look at number 31. So we have negative 1 on the outside. Write down the coefficients. We have 1, negative 5, negative 13. Insert a 0 for x, or a I should say, to the first, and then your constant. Make sure that when you guys are doing this, that the powers are in descending order. Okay, most of the problems are already set up like that for you, so you don't need to worry about it. So drop down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay. Now for 31, notice that we get a remainder again. Okay. And remember that when we write remainders, we write it as the quotient plus the remainder over the divisor. Okay. So we get a to the third, since we started with degree 4, minus 6a squared minus 7 plus 7 plus 3 over the divisor, which was a plus 1. All right, let's move on to a little bit tougher problems. Let's take a look at 43. By the way, if you wanted the answer for, sorry, this is 41. If you wanted the answer for 33, it was x to the fourth minus 3x to the third plus 2x squared minus 6x plus 19 minus 56 all over x plus 3. All right, let's take a look at 41. Like I said, we have 9d to the third plus 5d minus 8. Okay. Divided by 3D minus 2. Okay. Now hopefully you notice that we run into a kind of a problem here. And the problem is that the leading coefficient of the divisor is not 1. So we're going to divide everything by 3 to start. Don't mind, that was my dog just now. So this is now going to be d minus 2/3. So the opposite is 2/3. 9 divided by 3 is 3. Okay, we have a missing term for d squared. 5 divided by 3 is 5/3, and then minus 8/3. So once again, remember that when you are using synthetic division, the leading coefficient has to be 1. And then if not, you're going to divide everything by the leading coefficient so that you do get 1. Okay? So drop down the 3, multiply, add, drop it down, multiply, add. By the way, 9/3 is just 3, so I'm going to go ahead and erase this and make it just 3. Okay? And multiply and add. Okay. All right, so now we have 3d squared plus 2d minus 3 plus 2/3 all over that divisor that we recreated. But we can't leave our answer like this. There's a lot, you can't have a fraction within a fraction. So what you have to do is multiply this top and bottom both by 3. So now we get 3d squared plus 2d minus 3 plus 2 all over 3d minus 2. And that's your final answer. All right, so let's recap some things here. First of all, we had to divide everything by 3, the leading coefficient. Divide the dividend by 3 as well. Write down the coefficients. Work it out, use synthetic division. Okay. You get 3d squared plus 2d minus 3 plus 2/3 over d minus 2/3. Remember, you can't have a fraction within a fraction. This is a big no-no. So in order to fix that, you're going to multiply by whatever the denominator is so that you can cancel it out. In this case, both of our denominators are 3. So it works out nicely that we multiply both top and bottom by 3. And therefore you get 2 in the numerator and 3d minus 2 in the denominator. All right, let's take a look at 43 real quick. We'll just do the setup and then I'll have you guys do the problem on your own, since it was for homework last night. Divided by 2x plus 3. Okay. Once again, you have to divide everything by 2 due to the fact that the leading coefficient cannot be greater than 1. So we have negative 3/2, then we have 1, 3/2, negative 1, negative 3/2, negative 3. Okay. I will leave it up to you guys to find the answer to this problem. However, it is in the back of the book, so you can check your answers, but if you would like it, the answer is going to be x to the third minus x minus 6 all over 2x plus 3. All right, that concludes the synthetic division part. The next video will contain synthetic substitution as well as the lesson for the day, which is the remainder factor theorem.